Jai Shri Gurudev. Good morning to everyone students. In this class we are going to discuss some CET questions from the chapter Solid State, that is the first chapter. So here there are some questions, those are helpful to crack the KCET exam or JEE mains or IIT or NEET exam. Now let's take the first question. A solid X is very hard. A solid X is very hard and which is electrically insulated. In solid as well as molten state. Means in both solid as well as molten state, and it has extremely high melting point. What type of solid it is? So observe here, the question is what they are saying. They given a substance X to us. A substance X is given. This substance is very hard and electrically insulated, which is insulated in both solid as well as molten state. In both solid and molten state, this is insulated and it has extremely high melting point. Then we have to find what type of solid it is. They given four options here. Now ionic solid, covalent solid, metallic solids and molecular solids. These are the four options. Now observe the first one, ionic solid. Let's take any example for ionic solid, sodium chloride. So this is ionic solid. This ionic solid doesn't conduct electricity in solid state. Solid state alli electricity conduct ಮಾಡೋದಿಲ್ಲ ionic solid, so that we call insulated. But in solution state, molten means in solution state it conduct electricity, therefore it can be eliminated. You can eliminate ionic solids because in molten state it conducts electricity, but they said here both in solid and molten state insulated. And coming to covalent solids. Now take covalent solids, example graphite or diamond, etc. These are the covalent solids. Now these covalent solids are extremely very hard and high melting point. These covalent solids are extremely very hard and high melting point due to the presence of strong carbon-carbon bond. You know, covalent solids means presence of strong carbon-carbon bond. Therefore, they are very strong in nature and has high melting point. And they doesn't conduct electricity both in solid as well as molten state except graphite. Graphite ಬಿಟ್ಟು diamond ಆಗಿರಬಹುದು, silicon carbide, these are doesn't conduct electricity except graphite. Graphite ಬಿಟ್ಟು ಮಿಕ್ಕ ಎಲ್ಲಾನು ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಕಂಡಕ್ಟ್ ಮಾಡೋದಿಲ್ಲ. Therefore, the covalent solids are extremely high melting point due to the presence of strong covalent bond. Hence, the right option is covalent solid. Now, coming to metallic solids. How we have to conclude these two are not right answer. Now, coming to metallic solids. In metallic solids, take many metals like copper or iron or zinc, etc. These are some example for metallic solids. Either you take copper ions or zinc ions, etc. These metals are extremely very hard in nature. Therefore, they has high melting point, but they conduct electricity. Means they are the good conductors of electricity. You know, metals having some free electrons or free electrons in its valence shell. Therefore, they conduct electricity. Hence, these are not any insulator, so that we can neglect these metallic solids also. Now coming to molecular solids. You know, the molecular solids example, take iodine or hydrogen gas, or take molecules like nitrogen. These are some example for molecular solids. You know, molecular solids doesn't conduct electricity, they are purely insulated. Okay, these are purely insulated, therefore, and these are having less melting point, not high melting point. Molecular solids has less melting point, therefore this is not a right option. Now the right option is covalent solids. Okay, so that when you know the properties of these types of solids, definitely you will be answered within seconds. Okay, without knowing the properties you can't answer. So you should remember the properties, that is physical properties of these types of solids. Means four kind of solids. Now coming to next question. The second question is example of few solids are. The given examples of few solids are given below. Find out the example which is not correctly matched. So already we are discussing the first question only. Based on that, we can answer this one. So observe here, they given some types of solids and example. Which example is not matches correctly to the type of solid that we have to answer. Now take first one, ionic solids. The ionic solid is sodium chloride and zinc sulfide they given. So after ionized we get Na plus and Cl minus. It is easily ionized, and you know sodium chloride is a crystalline solid. Therefore it is best example for ionic solids that we face here only. Here also. So here similarly zinc can be ionized as Zn2 plus and S2 minus sulfide ion. So that these two are best example for ionic solids. Ionic solids. Now coming to covalent solids. Here covalent solids. Here observe H2, I2. These are the molecules. These are molecules. Here there is a bond between an hydrogen and hydrogen and iodine and iodine. These are not a covalent compound. These are molecules. Molecular compounds means molecular solids. So iodine and hydrogen gas are best example for molecular solids. That says here only. We says here also. So that is I2, H2, N2. These are the example for molecular solids. Now coming to molecular solids. Therefore this is not matched one. Not matches. Hence here the right option is this one. So exactly the correct options of covalent solids are graphite, diamond, silicon carbide. These are the example for covalent solids. These two are not matching to be here. Therefore this is the wrong option. But for the question this is the right answer. Okay. Then coming to molecular solids. Molecular solid water is the best example. Therefore it is also right one. Means it is matches. And similarly metallic solids, you know, copper and tin are the best example for metals. Therefore this is also matches. Here the not matching one is covalent solids. Okay. Now take third question. So coming to next question, that is the third question. The major binding force. The major binding force in diamond, silicon and quartz is. So observe here the given four options: electrostatic force, and electrical attraction, covalent bond force, and van der Waals force. These are the four types of force they given. Here the major binding force in diamond, silicon and quartz. So diamond is nothing but compounds of carbon. You know silicon. This is also like a covalent compound, and you know this quartz is best example for carbon compound. That is, all those three are best example for covalent compounds. So you know these all three is best example for covalent compounds. Therefore, definitely the covalent force of attraction should be present between these compounds. Andre ಮೂರು covalent compounds ಗೆ ಬೆಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಆಗಿರೋದ್ರಿಂದ ಅವುಗಳಲ್ಲಿ covalent bond force ಇದ್ದೇ ಇರುತ್ತೆ ಅಂತ ನಮಗೆ ಒಂದು 70% ಕನ್ಫರ್ಮ್ ಆಗೋಗುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಲ್ಲ? Then the remaining 30% should be concluded by the knowing the options. So here observe a given option 1 is electrostatic force. This electrostatic force of attraction is present only in ionic solids. Ionic solids ಅಲ್ಲಿ ಮಾತ್ರನೇ electrostatic force of attraction ಇರೋದು. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? This is present in ionic compounds. But here they given covalent compound, so that the option 1 is not right one. Then this electrical attraction is a type of force that attraction present between two opposite charges, that is positive and negative charges. ಎರಡು ಚಾರ್ಜ್ ಮಧ್ಯೆ ಇರುವಂತ ಅಟ್ರಾಕ್ಷನ್ ನಾವೇನಂತ ಕರೀತೀವಿ, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಅಟ್ರಾಕ್ಷನ್ ಅಂತ ಕರೀತೀವಿ. So this is just a type of attraction, not a force. Then covalent bond force. This covalent bond force is present only in covalent compounds. Here they given 3 covalent compounds. Therefore, definitely the covalent force only present in diamond, silicon and quartz. So that the option C is right answer. And coming to D, this is van der Waals force. This van der Waals force is a weak force of attraction present between the polar and non-polar compounds. Polar ಮತ್ತು non-polar compounds ಮಧ್ಯೆ ನಾವು weak van der Waals force ಅನ್ನು ನೋಡಬಹುದು. For example, take water molecules like H bond H. This is one water molecule, and this hydrogen is less electronegative, which is binding weak attraction present between the another water molecule of oxygen. oxygen. Like that type of bond we call hydrogen bond. That hydrogen bond is a type of van der Waals force of attraction. Okay. So here the right answer is covalent bond. Now coming to fourth question. So the fourth question is, which of the following forms a molecular solid when unsolidifies? When it solidifies. So solidifies is nothing but a process of conversion of liquid to solid or gas, liquid to solid, liquid to solids. ಅಂದ್ರೆ solidifies ಅಂದ್ರೆ ಸಾಲಿಡ್ ಮಾಡಬೇಕು, solidifies ಅಂತ. ನಾವು ಲಿಕ್ವಿಡ್ ಇರೋದನ್ನ ಸಾಲಿಡ್ ತರ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ? solidifies ಅಂತ process. The process of conversion of liquid to solid is called solidifies. Here among these options, which is a best example for molecular solids unsolidifies? They are asking that is, which of the following forms a molecular solid when solidifies? Now calcium chloride. This calcium chloride CaF2 is an example for ionic solids. Calcium chloride is an example for ionic solid. So this is not solidifies. This is not solidifies. So here following forms a molecular solid. Unsolidifies is calcium chloride not form a molecular solid. Then coming to silicon dioxide. Silicon dioxide is also not form a molecular solid. Unsolidifies because it is an example for covalent solids. This is example for covalent solid. This is example for ionic solids. And coming to carbon dioxide, this carbon dioxide unsolidifies, definitely gives a molecular solid. This carbon dioxide is unsolidifies, definitely become a molecular solid. Therefore the right option is C, carbon dioxide. So here observe, the silicon is a metal, non-metal. Silicon is non-metal, and the electronegativity difference between silicon and oxygen we are comparing. The silicon is less electronegative than carbon. Therefore it is not a high covalent solid. However it is not a molecular solid. However it is a covalent solid. Then this is an example for molecular solid. And coming to sodium chloride, the sodium chloride is a best example for ionic solids. Therefore the right answer is carbon dioxide. Like that you are confirming. Then take next question. The fifth question is, observe, which of the following solid is a structure of CsCl crystal? CsCl crystal, that is cesium chloride crystal. The cesium chloride crystal structure is, among these they are asking simply, what is the crystal lattice structure of cesium chloride among these? The first one is BCC, means body centered cubic crystal, simple cubic crystal, face centered cubic crystal, and edge centered cubic crystal. These are the four options. Now observe, in the cesium chloride, the atomic mass of cesium is higher than the atomic mass of chloride. The atomic mass of cesium is higher than atomic mass of chloride, and after ionizing, this chloride carries negative charge and cesium carries positive charge. Therefore in a crystal unit cell or in a lattice, let's say this is a crystal lattice, means a unit cell of crystal lattice. We are taking a unit cell. In this unit cell there is a head corners and one center, body center, and there is six face centers. Due to the high atomic size of cesium and less atomic size of chloride, the chloride ions, the Cl minus ions, is occupied at corners of the cubic crystal, and the cesium positive charge ion is occupied at center of the crystal, and the resultant lattice is called body centered cubic crystal. Therefore the right answer is A, BCC. So here the circle is what? Means that this shaded atom is called cesium, and these circles is called what? Chloride ions. So write the chloride ion is less size because it is hard ion and less atomic number, and you know anions are high size than cations, but we are comparing the atomic size. So this is called chloride ion. This shaded atom is called what? Cesium. So resultant structure you get like that. That is, hence the right answer is B6. Okay. So this is the simple. The cesium chloride is best example for body centered cubic crystal. And now observe here, the chlorine ions are present at the corners, which is surrounded by the cesium positive charge. Now take next one. The sixth one. Which of the following primitive cell? Which of the following primitive cell? Which of the following primitive cell shows the following parameters? Here they given the parameters. Alpha is not equal to beta, which is not equal to. A is not equal to B, which is not equal to C. The given parameters for a crystal primitive cell, A is not equal to B, which is not equal to C. And they given alpha is equal to beta, which is equal to gamma, and all these are equal to 90 degrees. Here they given primitive cells, cubic primitive cell and tetragonal primitive cell, orthorhombic and hexagonal. Among these, which is the right answer? Here the right answer is orthorhombic. Right answer is orthorhombic. Now let me have to know how the orthorhombic is right answer for these parameters. I told you a trick how to remember these parameters in the beginning of the solid state chapter only while explaining the theory. So let me have to discuss once again. So observe, there is a trick to remember these parameters of different primitive cells. There is a basically 7 primitive cells. Those we are how to remember. We will give a trick. So observe, let's take dimensions and angles. These are the dimensions, and these are the angles. Now let's take first to write. Observe CT, OT, HMT. CT, OT, HMT is a trick to remember dimension. Then first one, C means cubic. T means tetragonal, orthorhombic, and triclinic, trigonal, and hexagonal. This is monoclinic, and this is triclinic. Like that. This is the simple way to remember. That is CT, OT, HMT. Cubic, tetragonal, orthorhombic, triclinic, hexagonal, monoclinic and triclinic. This trigonal is called as rhombohedral. Trigonal is called as rhombohedral. Now for cubic, alpha is equal, cubic, the dimensions are A is equal to B is equal to C. For cubic, the dimensions are A is equal to B is equal to C. And similarly, for tetragonal, A is equal to B, which is not equal to C. Then for orthorhombic, A is not equal to B, which is not equal to C. Then similarly, repeat these three again, same as it is. For trigonal, A is equal to B is equal to C. And for this one, A is equal to B, which is not equal to C. Then for monoclinic, A is not equal to B, which is not equal to C. And write this one same for triclinic. That is, A is not equal to B, which is not equal to C. So this is the way of writing dimensions for these lattices, primitive lattices. Now coming to angles. For the angles, there is alpha, beta, gamma angles, which is equal to 90. Now write first that one. That is, alpha is equal to beta is equal to gamma, which is equal to 90 degree. Again write for same. Alpha is equal to beta is equal to gamma, which is equal to 90 degree. Similarly, for orthorhombic also, alpha is equal to beta is equal to gamma, which is equal to 90 degree. Okay, then last one, triclinic. For triclinic, alpha is not equal to beta is not equal to gamma, which is not equal to 90 degree. So all these are not equal to 90 degree. For triclinic. Now trigonal. For this one, alpha is equal to beta, which is equal to 60 degree. 60 degree. Then gamma is equal to 120 degree. Gamma is equal to 120 degree. Then for hexagonal, so got it? Listen. For hexagonal, alpha is equal to beta, which is equal to 60 degree, so which is 90 degree, and the gamma is equal to 120 degree. Similarly, for monoclinic, alpha is equal to gamma is equal to 90 degree, and the beta is equal to, means beta is not equal to 90 degree. This is the way to remember the dimensions and angles. If you know these parameters, definitely you can answer such kind of questions. Definitely they give one question from primitive lattice for your KCET exam, or in KCET exam definitely you get one question based on primitive lattice. So observe here for angles alpha, beta, gamma is not equal to 90 degree and 90 degree for these three. Here observe alpha, beta, gamma, all these three equal to 90 degree. So here equal to 90 degree. But here observe the dimensions A, that is not equal to B, which is not equal to C. So here observe this is not equal to C. Its name is called what? Orthorhombic. Therefore the right answer is C. Okay, if you know the dimensions and angles of a primitive lattices, you can answer such kind of questions. Now take one more example on the basis of same. So listen, this question already asked in KCET exam, one of the KCET exam. The question is the unit cell with crystallographic. The unit cell with crystallographic dimensions are, that is alpha is not equal to beta, which is not, A is not equal to B, which is not equal to C, and alpha is equal to gamma, which is equal to 90 degree. Then beta is not equal to 90 degree. Among these, which is the right answer? The first option is orthorhombic, triclinic, and tetragonal, and monoclinic. These are the options. So observe here, alpha A is not equal to B, which is not equal to C. So here there is two options only, that is A is not equal to B, which is not equal to C, one option, and here one more. There is two options. There are three options here, these three, according to the first condition. Now second one, observe alpha is equal to gamma, which is equal to 90 degree, and beta is not equal to 90 degree. There is only one condition, beta which is not equal to 90 degree, that is here. So observe, beta is not equal to 90 degree and alpha gamma is equal to 90 degree for what? Monoclinic. So here they given monoclinic. This is the right option. Like that you have to be answered. Definitely one question come from this concept. Okay. Now take next one. Listen. The next question is coordination number of cesium cation and chloride anion in cesium chloride crystal are the given options 8, 8, 4, 4, 6, 6 and 8, 4. So you know the cesium chloride is best example for body centered cubic crystal. Already I told you, the lattice crystal lattice unit cell. This is unit cell, and I told you the chloride ions are present at the corners, and the cesium ion is present at the center of the body. Okay, center of the body. This is the example. This is the structure of representation of BCC crystal lattice of cesium chloride. Now observe this cesium ion, one cesium cation is surrounded by how many chloride ions? 1, 2, 3, 4, 5, 6, 7, 8. 8 chloride ions is surrounded by one cesium ions. Similarly, here there is one more crystal lattice in this side. ಇಲ್ಲಿ ಇನ್ನೊಂದು crystal lattice ಇರುತ್ತೆ ಈ ತರ ಇನ್ನೊಂದು crystal lattice ಇರುತ್ತೆ So observe, there is one more crystal lattice here. Like that. So observing, there is one more crystal lattice, and similarly in the top also there is one more crystal lattice like that. Like that, there is a top as one more crystal lattice. So observing like that, one crystal lattice is surrounded by again 8 crystal lattice around it. Therefore, this chloride ion also surrounded by 8 chlorine anions. Sorry, the cesium ion also surrounded by 8 chlorine anions, and one chlorine anion also surrounded by 8 cesium cations. Therefore, the coordination number is 8, 8 in BCC. Remember, in coordination number of a crystal, which is the best example for BCC, that having the coordination number 8, 8. Okay. Now, similarly observe the next question. How many chloride ions are surrounding sodium ion in sodium chloride crystal? How many chloride ions, Cl- ions, surrounding sodium ions in sodium chloride? Similarly, same type of questions. Now observe in sodium chloride, Cl- and Na+, sodium chloride. Here, how many chloride ions is surrounded by one chloride ion, sodium ions. How many chloride ions are surrounding sodium ion? One sodium ions ಇತ್ತು, ಎಷ್ಟು chlorine ions ಇರುತ್ತೆ ಅಂತ ಕೇಳಿದ್ದಾರೆ in the question. Okay, now observe in the crystal lattice, let's take this is a sodium ion. In this crystal lattice, let's take so observe, let's take write a Brevis lattice or see observe, this is a crystal lattice. So observe, in this crystal lattice, let's take here, this is one of the crystal lattice. We are writing cubic unit cell. In this crystal lattice, let's take one cubic crystal. Let's take this one. So observe, take any one of the crystal lattice. Let's take this one. This is the one of the crystal lattice, center of the unit cell. Center of the crystal cell. You take one unit cell. In this unit cell, one atom is surrounded by 4 atoms in the same plane. One atom is surrounded by 4 atoms in the same plane. Same plane and 1 to 4 atoms in a surround agide. And one more atom is above the plane and one is below the plane. Like that, observe, if a atom which is surrounded by 4 atoms in the same plane, and one atom is above the plane and one atom is below the plane, like tetrahedron. Like these are the 4 atoms present in the same plane, and one more atom is present above the plane and one is below the plane. Like that, in sodium chloride, the anions are surrounded by cations, and similarly the cations is also surrounded like that. Hence, the correct option is 6. Okay, like that the arrangement is occur in sodium chloride. Therefore, the number is 6. Is the surrounding cations. So listen, the next question is the H length of a sodium chloride unit cell is 564 picometer. H length, that is the H length of a unit cell is 560 picometer. They given, so observe, they given A is equal to how much? 564 picometer. H length A, that is pico means 10 power minus 12 picometer. And the size of the chloride ion, anion, Cl- ion is given 181 picometer, and the size of the sodium ions will be, they ask to calculate size of the cation, and the given options here 101 picometer, 181 picometer, 110 picometer and 202 picometer. So now observe, to calculate this sodium ion size, we know the formula that is 2r is equal to a. 2r is equal to a, that is radius of the cell is equal to edge length a. Radius of the cell is equal to edge length a. Now here radius means the size of the cation as well as anion both. In the crystal that is sodium chloride. Sodium chloride is ionizes into Na plus and Cl minus. There is two ions. We have to take both the radius ions. Means radius of both the ions. So that this R can be written as radius of Na plus ion plus radius of Cl minus ion. That is take 2 into radius of Na plus ion plus radius of Cl minus ion, that is equal to A. Okay. Now they given A, that is equal to 2 into radius of Na plus ion. How much they given? They has to calculate. So write radius of Na plus ion plus radius of Cl minus ion. How much they given? 181 picometer. That is equal to A is edge length, that is 564 picometer. Okay. Now take 2 to this side, that is radius of Na plus ion plus 181 is equal to 564 divided by 2. We are doing cross multiplication. Now radius of Na plus ion is equal to 564 divided by 2. How much you get? So divide that one. 2 divided by 564. 2 ones are divide 564 divided by 2. 564 divided by 2. 2 2s are 4. 1 2 8s are 16. 4 2 2s